Hello and welcome back to the wrap-up video for Chapter 9. Here's where we left off. We were getting ready to talk about a tough subject, multi-protocol label switching. This is a newer protocol that I don't have any hands-on experience with, so I can only show you in theory what it does. It does some pretty interesting things. So with that, let's jump into this. And let me get ready here. Okay, so remember what a router does. A router passes packets by doing a lookup in a router table. Specifically, there are 3 steps. I'll pause while you remember the 3 steps. You don't remember? First step, find all the possible matches in the table. Step 2, find the best match. Step 3, send the packet out the outgoing interface. So in remembering those 3 steps, every single time a packet comes through, it's got to go through and determine all the possible matches. So the problem is that this can take a lot of processing power per packet, which can make just adds to administrative overhead. It slows things down. Wouldn't it be great if the router didn't have to do a manual lookup for every single packet? Well, MPLS solves that issue by identifying the best route beforehand based on a range of IP addresses that you define as the network administrator. So it only does a quick table lookup of those pre-identified routes, which is a lot faster than the traditional form of routing that we've been talking about. Not everybody uses MPLS yet. I mean, I kind of grew up using frame relay, but I know a lot of companies are replacing frame relay for their WAN connections with MPLS. So this is a kind of a hybrid protocol. It's mostly a wide area networking protocol. So this is what ISPs are using to exchange information with each other. It's less of a protocol that you're using inside the network, inside the corporation. So since there's not one company that owns all the ISPs, it's hard to kind of roll out MPLS in a coordinated effort. So that's why you have these peering arrangements where two or more ISPs agree that they're going to start using MPLS because it's more efficient. MPLS is called a layer 2.5 protocol. That's weird to me, but it's designed to carry old IPv4 traffic and also the newer IPv6 traffic, as well as ATM traffic, SONET traffic for wide area network, as well as Ethernet frames. And of course, that's a local area networking technology. That's why I said it was a hybrid protocol. That's weird to me. That's why I say it's freaky. So with that, I just want you to be able to recognize MPLS as a new protocol. With that, let's jump to the next section of securing internet transmission with VPNs. So a VPN, a virtual private network, simply encrypts traffic over a public network. So for example, using the internet, that's very, very public. It's the most public network, right? So you want to have a way to keep your traffic secure from hackers and whatnot, and a VPN is a fantastic way to do that. So it's like having your own private network, but it's not really having a private network. If you wanted to have a real private network, you would lease a T1 line from the phone company between 2 locations, and it'd be a dedicated line such that the only traffic that's going over that line is your traffic. That would be a true private network, but this is virtually private. And of course, virtually is a euphemism for not. I'm virtually working means I'm not working. I'm virtually studying. I'm not studying. It's virtually private. It's not private. But it's pretty good and a cost-effective way to do it. So there are two main types of VPN. This is test-worthy. The first one is called a remote access VPN. So I don't like how they use a little PC here because it'd be more accurate to think in terms of having a laptop that you're using remotely out in the field. Or I know there's a group that's doing a project around VPN over tablets. That'd be a similar type of remote access VPN. So there's just a software client that encrypts all the traffic that's going out over the wide area network. That has to talk to some kind of box at the corporate location. This VPN gateway might be called, if it's Cisco, it's going to be called a VPN concentrator. It might be called a gateway. It might be called a security appliance. It might just be called a plain old firewall. Or even some specific type of router that has VPN built into it. So there are a lot of kind of industry marketing terms for what this box is, but we'll just call it a VPN gateway for now. And the second type is if you're in like an office setting, like a remote sales office, 5, 10 people. This is an inexpensive way and you don't want to pay for a dedicated lease line from the phone company. Maybe you just want to set up a permanent VPN connection. It's always on. It's always encrypting traffic, but it's site to site. One of the advantages is this is faster because now you've got a VPN concentrator on both sides. Notice there's a box here. There's a box here. You're not putting a piece of software on all 10 client PCs to encrypt traffic. You're just doing it here. And of course, as we all know, hardware encryption is always, always, always faster than software encryption. I am so sorry about that. Don't you hate it when you're recording a video and the dog starts barking because somebody's at the door? Anyway, where was I? Oh yes, that as we all know, hardware level encryption is always going to be faster, more efficient than software level encryption. So that's why this is probably a better solution, especially if there are multiple people in the office, but it does require more hardware and it's a little more expensive. So that's the second way to implement VPN. Both VPNs are using a security protocol called IPsec, which stands for IP security. It's not complicated, but we just call it IPsec. Okay. And the other issue with VPNs like this is an issue of split tunneling. So the question becomes where your internet traffic is going to go. So say you're on a laptop in a hotel in Las Vegas remotely. You can access the hotel's internet so that it goes out unencrypted, straight to the internet, or the internet traffic, if you're encrypting all traffic, well, that includes internet traffic. So if you're just browsing a web page, it's going to go across the VPN, encrypted, therefore slower, go through the corporate network, and then back out to the internet, and then back to your machine, which obviously isn't as efficient. So a lot of network administrators make use of split level tunneling so that only traffic that's destined for the corporate network goes over the VPN, and all other traffic goes out unencrypted to your regular internet connection. And how does it do this magic, you may wonder? Of course you know the answer. It's by IP address, right? So you tell it this range of IP addresses that's part of my corporate network. This is the traffic that I want to go out the VPN virtual interface. Okay, so that's how split level tunneling works. I've got it in green here because I wouldn't test you on it, but this comes up frequently in the real world, so I wanted to kind of give you some background on it. Finally, after the book says, well, there are two types of VPN, then it gives you a third type, right? The SSL TLS type of VPN, which is the most inexpensive type of VPN. It's the cheapest because it's not encrypting all traffic. All it's doing is just encrypting the traffic between your browser and a single web server. And I say a single web server, not all web servers, is because it's site by site. So you can tell you're using an SSL TLS certificate when you've got an S for security after the HTTP. It's very widely used because it's the cheapest of the three forms. It is not using IPsec, it's using its own protocol, SSL TLS protocol. Originally created by Netscape, blah, blah, blah. We should just refer to it as the TLS standard now, but we got used to saying SSL so much, that's why everybody tends to say SSL TLS, which is a mouthful. It's nice because, as far as I know, every browser, every web server platform supports it, and there's no extra software needed. But the company that owns the web server does have to purchase an SSL certificate. So very briefly, ignore this link. It's a dead link now. It doesn't matter because that's from 2 years ago. But let me show you this link real fast for, oh my gosh, how am I going to do this? I'm going to do it like, wait, not that one, this one. If you do a little research on SSL certificates, some of them are pretty cheap. GoDaddy seems to be the cheapest, but there are lots of companies. VeriSign is a very kind of corporate-friendly sort of place to use. GoDaddy, if you don't care about the stigma of naughty Super Bowl commercials with your SSL certificate. Google even does it now. So there are lots of places to get these certificates. And let's see. Obviously, this TLS is for transport layer, so we're operating at layer number what? 4. Yes. So SSL TLS work at layer 4, not layer 3 for routing, but layer 4 for authentication encryption. And it just works with HTTP traffic, email that's running over your browser. It's weaker than IPsec. It's been partially cracked. It's still pretty good. It's pretty good. I mean, I feel comfortable buying stuff on Amazon and whatnot. So just for comparison, IPsec is the gold standard in the sense of it's the best thing, the most widely used form of encryption out there. SSL TLS is cheap. It's pretty good. It's easily managed. IPsec is pretty versatile. It can be used for all types of VPNs. However, I never want you to try to mix and match brands. So I think I talked about this in class. Don't try to get a Cisco box to talk to a WatchGuard box and set up a VPN. Theoretically, it's possible, but it's the details around getting all the configuration settings to line up exactly right are devilish. I really don't recommend that you ever try to do that. Okay, with that bit of advice, now we can jump to IPv6 management. And yeah, let's keep going. So as the world moves from IPv4 to IPv6, it means we have to change our operating systems. It means we have to change our routers, our firewalls. This can get expensive, and companies in general don't like to spend money when they have to. So you have to kind of explain to your company how, well, we're out of IPv4 addresses, and eventually everybody's going to be using version 6. We've got to switch at some time, so we've got to come up with some kind of transition plan. There's no backward compatibility, so what you're doing is you're running both versions at the same time on all of your network gear. And then once everybody switches over to IPv6, you just turn off IPv4 on your router, and it's got that much less work to do. So you'll gain some efficiency there. I was curious about what the timeline for this was, when the ISPs were going to switch over to using IPv6, and found out that, in fact, we already had that. We had a test day on June 6, 2012, that was successful. And we even have a logo and everything for World IPv6 Launch Day. I know you're celebrating that day at home with a kegger, but here's some information on the test day and the people that were participating: Facebook, Google, Yahoo, a lot of major providers were testing this out, and it worked just fine. A year later, they did a second launch to actually go live, and let me show you some statistics here on the rate of adoption. This shows the lines growing for different regions, but notice even up here you're only at 10-11%. So, and like this is up through. There's my timer. Thank you. I've got a minute left before I have to stop this video due to YouTube's 15-minute limitation. But just take a look at the rate of adoption. It's still not at 80% or anything like that. It's hovering around 12-13%. You can see where adoption is really taken off. But this is an interesting site just to keep up with. So on this slide, I'm going to pause and do the next video. So hang in there.